Okay, Bitcoin. We've all heard the name, right? You've seen the crazy headlines, but how does it actually work? Under the hood. What if we could invent it ourselves, right now, just from first principles? That's exactly what we're gonna do. We're gonna build the world's first truly scarce and decentralized digital money from the ground up.
And look, this isn't just about some quirky internet money. As Jan Pritzker says, this is the kind of thing that might only come around once in a lifetime. Think about it, like the printing press or the internet itself. So you have to ask, what was the problem? What problem was so massive that it needed a solution this revolutionary?
Well, it really all boils down to one simple, powerful, and very human word: trust. See, to really get why Bitcoin was even invented, we first have to take a hard look at the system we already have, the one it was built to replace. Every single time you swipe your card or send money with an app, you're trusting someone else, a third party. Could be a bank, a credit card company, a payment processor, you name it. You're trusting them to hold your money, to keep your private data safe, and, this is a big one, not to just print more and more money until yours is worthless. Bitcoin's creator, the mysterious Satoshi Nakamoto, saw this total reliance on trust as the fatal flaw, the Achilles heel of all digital money.
Just think about your bank for a second. They're basically a central bookkeeper, right? They hold the one true ledger of who owns what, and every single transaction has to get their stamp of approval. And that right there is a huge problem. It's a single point of control, and maybe even more importantly, a single point of failure.
Okay, so if we're inventing our own system, step one seems pretty obvious. Let's get rid of the middleman. If we don't want one single company or bank in charge of the ledger, well, what's the alternative? Well, the first idea you'd probably have is the simplest one. What if we just give everyone a copy of the ledger? Instead of one bank controlling the whole book, we all have our own copy. So if Alice wants to send money to Bob, she just yells it out to the whole network, and we all jot it down in our own ledgers. Easy, problem solved, right? Not so fast. Because in a network like this, where literally anyone can join and nobody knows who anybody else is, you've just created a brand new, massive problem. If my ledger says one thing and your ledger says something different, whose ledger is the truth? And this leads us straight to a critical, potentially system-destroying flaw. It's called the double spend attack. And it's basically a way to counterfeit digital money, to create it from thin air. Let me walk you through exactly how it would work. Okay, so imagine Alice has just $2 to her name. She sends it to Bob to buy, a coffee. But, and here's the trick, she and a bunch of her friends, who happen to be a majority on the network, all keep their own version of the ledger where that transaction never happened. So when a new person comes along and joins the network, they look around and see that most people's ledgers say Alice still has her $2. And just like that, she can spend that exact same money all over again. What we're looking at here is a total failure of consensus. It's actually a famous problem in computer science. How do you get a whole bunch of people who don't know or trust each other to all agree on a single version of the truth? Especially when you know some of them are probably trying to lie. And this is where the genius of Satoshi Nakamoto really, really shines. The solution that was proposed was, it was completely counterintuitive. It was elegant, and it absolutely changed everything. See, the big breakthrough wasn't about trying to find someone you could trust to run the whole thing. Nope. It was about flipping the whole problem on its head, changing the rules of the game completely. Instead of relying on trust, the system would rely on cost. It's designed to make being honest the most profitable strategy and to make cheating just ridiculously expensive. This elegant solution has a name. It's called proof of work. And what it does is it forces anyone who wants to write the next page of the ledger to first prove they've burned a real-world costly resource. We're talking about electricity. By doing this work, they're proving they have real skin in the game. They have something to lose if they get caught trying to cheat the system. And this whole process of performing that work, that's what we call mining. You can think of it as the engine room of the whole network. It's what secures everything, what validates all the transactions, and, this is the really cool part, it's also how new Bitcoins are actually born. So what is this work? Well, at its core, it's basically a competition to solve a puzzle. But it's a very special kind of puzzle. It's what we call asymmetric. It is incredibly, brutally difficult and energy-intensive to find the answer. You can think of it like guessing trillions and trillions of random numbers. But, and this is the key,
Once somebody finds the answer, it is super easy for everyone else on the network to check and see, yep, that's the right one.
The tool that makes this puzzle possible is a mathematical concept called a hash function. It sounds complicated, but the idea is simple. You can feed it any digital information you want, say a list of transactions, and it spits out a giant, totally unique, and completely unpredictable number. If you change even one tiny thing in the input, like a single comma, the output number changes completely. It's a digital fingerprint. And it's a one-way street. You can't work backwards from the number to figure out the original data.
So, how does this become a lottery? Well, to win, a miner has to keep guessing random inputs until they find one that produces a hash number that's below a certain target number. Imagine you have a die, but instead of 6 sides, it has trillions upon trillions of sides. And to win, you have to roll a number that's less than, say, 100. There's no skill involved, you just have to keep rolling and rolling and rolling.
And folks, that's it. That is mining. It's literally millions of specialized computers all across the planet, all guessing numbers as fast as they possibly can 24/7, all competing in this massive global lottery. And what's the prize for winning? The winner gets the right to bundle up all the most recent transactions into a block and add it to the official ledger, the chain of blocks, the blockchain.
But why on earth would anyone spend so much money on computers and electricity to do this? It all comes down to a powerful economic incentive. As their reward for winning, the miner gets to include one special transaction in the new block, a transaction that pays them brand new, freshly minted Bitcoin. That's the motivation. That's what gets people to spend real-world resources to secure the network and, most importantly, to play by the rules.
But here's a crucial difference from, say, the US dollar. This money creation isn't random or decided in a boardroom. It's hard-coded right into the software itself. The key thing to understand here is that Bitcoin's supply is absolutely fixed and predictable. There will only ever be 21 million coins. Ever. And the reward that miners get, well, that gets cut in half about every 4 years in a famous event called the halving. All of this means Bitcoin has a monetary policy that's totally transparent and, above all else, verifiably scarce. And there's one last piece to this puzzle. Another stroke of genius, really. The network has a kind of built-in thermostat. It's called the difficulty adjustment. If a ton of new miners join the network and start finding blocks too fast, the system automatically makes the puzzle harder. It makes that target number even smaller. If miners leave the network, it gets easier. This beautiful little mechanism ensures that a new block is found on average about every 10 minutes, like clockwork. So there you have it. That's the whole system. That's what we just invented, step by step. We've got a peer-to-peer ledger that nobody owns and nobody can control, a system secured not by trusting people, but by the provable physical cost of energy. And the whole thing is powered by a currency with a predictable, unchangeable supply. A currency that no one person, company, or government can ever tamper with. You see, by solving this deep problem of trust, Bitcoin really achieves something pretty monumental. It achieves for the first time a potential separation of money and state. It opens the door to a possible future, a global financial system that doesn't need banks or credit card companies or any central gatekeepers at all. And that leaves us all with a very big and very profound question to chew on. What would a world like that actually look like?